The ball valve came into large-scale industrial use during the 20th century. With a hollow and pivoting ball to control the flow of fluids, this valve is durable and resistant to contamination. It's why many industries rely on ball valves to keep production flowing. Ball valves control the flow of gases in machinery used to produce high-tech products like LED lights. It's just one way they contribute to the modern world. Making ball valves for LED manufacturing starts with an 11-foot-long steel bar stock. As coolant flows, a saw carves it up like salami, producing 50 or 60 steel pucks. Computerized tooling then drills holes in the pucks as it begins to transform them into the valve's center parts. The system changes tool bits automatically. Cutters square up the pucks so that they'll fit in the LED chip-making machinery. A grinding tool mills the tops of the parts to a precise tolerance. Once the final shape has been achieved, a worker gives the part a sanding. He removes rough bits known as burrs and smooths the entire surface. With a narrow blade, he then scrapes off any burrs in the holes that could impede the valve's function. With the deburring complete, he measures each valve body. Ceramic bits that look like aquarium gravel will now be used to polish the steel valve parts. The operator places the valve bodies in the cells of a drum tumbler. He puts the lid on the tumbler and sets it in motion. The friction polishes the steel, creating a smooth surface that won't block the movement of gas molecules. Next, they assemble flanges to the end caps. After tack welding the two parts together, an operator places them in a revolving fixture. He welds them together, creating a substantial inside seam that will hold up to vacuum conditions. He scrubs off the heat stain inside the part using a wire brush. The stain has also spread around the seams on the outside of the parts, so a worker rinses the outside of the seam with water. He washes off the stain using an electrified carbon brush and an acid cleaning solution. Then it's into an ultrasonic cleaner where sound waves ripple through water to remove dust and cleaning solution residue. To assemble the ball valve, the technician places two rubber O-rings on top of an end cap. Next is a thick synthetic ring which will secure the ball in the valve. He seats the valve body over it. He cleanses the hollow steel ball and inserts it in the valve body. He stacks more rubber sealers, another synthetic sealer, and another end cap on top. He inserts long bolts into the four corners of the valve and secures them tightly with nuts to keep air from seeping into the valve. He attaches a handle to the stem protruding from the valve body. He installs a stop pin to prevent the handle from opening beyond a quarter turn. Finally, he tightens the nut that locks the handle to the valve stem. He now secures the ball valve in a vise to hold it steady while he tests its function. When the hole of the ball is aligned with flanges of the end caps, the valve is open, and when it's perpendicular to it, it's shut. Satisfied with its function, he transfers the ball valve to the laser engraver. The laser etches the serial number and other information onto the valve body. And now one final test. The technician connects the valve to a vacuum pumping system and activates a leak detecting device. While the pump draws a vacuum, he sprays helium gas onto the valve to detect any leaks. This ensures the valve will operate properly in a high vacuum environment. Some of these ball valves are manually operated and others are computerized. Both versions are designed to hold up to high vacuum conditions and handle the flow.